But this is the second lab for this course. I'm going to be demonstrating one of two programs here that you're going to be writing for me and submitting to me through Blackboard. So the first program is it's a motor start-stop program here. We have two start buttons here, start 1 and start 2, and we have a start button over here. So these are our three inputs into the PLC right now, and I've got them all wired up here in front of us. And then these are our two outputs that our output card on the PLC is running. So what happens here is when we push start 1, the motor 1, M1 here, turns on and stays on. And if at any time I push stop here, it shuts off. Now if I push it again here, the only way that M2 here starts is if M1 is already on. So M1 needs to be on, and then when we push start 2, M2 will also turn on. And you can see how they're both running. If at any time we push stop, both motors shut off. And the way that we should write our program is if M1 for whatever reason ever does get turned off, if the PLC, someone on the PLC forces it off or anything like that, M2 will continue to run. So that gives you a hint as to where to place the logic there for starting up M2. So push start, M1 turns on, then M2 can turn on, and if at any time we push stop, both motors will shut off. Okay, so now the important thing here about when you write your programs is I want your base tags or your direct addresses to correspond with the wiring I've laid out here, because normally if this was an in-person lab, you would be wiring this up. So the way that this is set up is we have, you can see two leads connected to the positive of our 24 volt power source. One of the leads runs up over here for our output card. And then all of our outputs are ran out and down to our lights over here. The other one runs over here to our fuses for all of our inputs. And you can see, so this lead right here is the other lead that's coming from our positive on our power source over there. So this is going up to all of our fuses, and then out from our fuses, this runs down to our switches, all three of these wires for the three switches, the start 1, start 2, and stop. And so if we look here, start 1's on 17, start 2's on 18, and stop is on 13. So that's these three right here. And so this side here, this side over here is all coming from our fuses if we need to individually isolate those switches. So 13, let's just follow these now. 13 runs up. This is where it can kind of get, just get this pulled out. So 13 runs up and goes into our, this would be terminal, we have 1, 2, 3, 4, 5, into terminal 5. And so that was 13, which is stop, goes into terminal 5. And now 17 we're gonna look at. So 17 runs up and goes into terminal 1 right here. So start 1, which is 17, goes into terminal 1, and then start 2 leaves our last one here, which goes into terminal 3. So by knowing that start 1, start 2, and stop are in these three terminals, we should be able to then determine which bit number they have been wired to on our PLC. Looking back to lab 1. For our discrete outputs here, which are our LEDs here, we've got 1 and 2. 1 and 2, 1 is M1 and 2 is M2. So that makes it fairly easy for us. And if we trace these back here, the top one there, which is terminal number 1 here, terminal number 1 goes down to number 1. So terminal number 1 is M1 and terminal number 2 is M2. So terminal number 1, sorry, and terminal number 3, sorry, this would be terminal number 2, which is where our power is coming in. Terminal number 1 and terminal number 3, M1, M2. So by knowing that information now, we should be able to correctly address our two lights, M1 and M2. We should be able to address those properly on our discrete output card. All right, so you're gonna go ahead and write the logic for that program, and then when you're done writing the logic, you're going to print this to PDF. So right here I've just got a quick example. This isn't the correct logic, but I've got an example here of some logic that I'm going to print for you. So if we go up to File, and then we go to Print, and we go to Routine, then we can print it to a PDF file, and we'll save it as Lab 1A. I've already saved a copy there. Save it as Lab 1A, press Save. And then it should pop up here. Might have to go to the desktop, open up, and there's our logic. So this is the file that you'll submit for the first program. All right, so the second program that you're going to write, we have M1 over here still. You notice how M2 is now gone. In this program, when we push Start, M1 will turn on. But if at any time we push this normally closed stop button over here, it'll shut off, and I won't be able to start it again. So it's stopped and locked out. The way that we unlock it is if we push this reset button, we should then now be able to start it. So stop will lock out the motor. We can't use the start button until reset is pushed. And the only thing that's really changed for the wiring here is I removed the wiring for M2 because we're not using it here anymore, but all the other wiring stays the same. I used the normally open push button here that was used for start 2 is now reset. So that's the only thing that's changed for the wiring. So that should give you the information you need for assigning the right bit numbers to the inputs and outputs on the PLC. So once you have completed both of your programs and printed them to PDF, you'll come into Blackboard, into the course, click on Labs, and there should be a Lab 2 link here that you click. You can see that I have the instructions here on how I'm going to be grading the lab based on the tag, addressing and labels, functional logic, and program housekeeping. So these 9 marks apply to the 2 programs that you submit. If I click on that link, down here there's a spot to browse my computer for files, so we click on that, and I've saved them to the desktop here, Lab 1A and Lab 1B. So Lab 1A is the first program, Lab 1B is the second. And I click open here after I've selected them, and you can see that it adds them down here. And now if you have any comments or anything to add here, you can do so there, and then click submit, and submit will send it to me. Then I'll grade it, and once again I just wanted to highlight that I'm going to be grading it based on these 3 things. Each time that I find something incorrect, I'll be removing a mark. So there, that should give you the information you need for submitting this lab. Good luck.